All right, here we are back at it. Homework 2 practice problems. Let's go. Find the x and y intercept of the line. So the x-intercept is where y is equal to 0. The y-intercept is where x is equal to 0. And then you solve. So, all right, so for the first one, x-intercept, 6x minus 4 times 0 is equal to 21. That's showing my y is equal to 0. That's my x-intercept. Yes. All right, so that means that this goes away, it becomes 0. So 6x is equal to 21. So x is equal to 21 over 6, which is equal to, divided by 3 is 7 over 2. Your y, oh, I divided both sides by 3 here. Sorry, skipping steps. So for my y-intercept, 6 times 0 minus 4y is equal to 21. 6 times 0 is 0. So I get negative 4y is equal to 21. Divide by negative 4. And I get y is equal to negative 21 over 4. And that is my y-intercept. Oh, I guess I could have written it here. X-intercept is equal to 7 over 2. And y-intercept is equal to negative 21 over 4. All right. Find the equation of the line below. So we have 2 points. So the first point we have is at negative 3, negative 3. And the second point is at 3, 6. First thing we need to find is the slope. The slope is equal to y sub 2 minus y sub 1 over x of 2 minus x of 1. Okay, this really just means starting at one point, what is the, and I'll write it like this, what is the change in y value over the change in x value? Okay, that delta, that triangle is called delta. That's a term you start using in calculus. Okay, but we're going to do the short version. We'll do the high school version of this. Okay, in other words, I start at this point and I figure out my change in y value. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then my change in x value. 1, 2, I want to do it like this. 1, 2, 3, 4, 5, 7, 8, 9. My change in x value is 1, 2, 3, 4, 5, 6. Hold on. 1, 2, 3, 4, 5, 6. Got to land with them. So 9 over 6, which if you simplify that, that is 3 over 2. Okay. Now, this is this point right here. That is the y-intercept. If we knew where that was, which we have an idea of where it is, but if we knew where that was, we could just plug it in and we're done. Y is equal to mx plus b. We know what m is. M is 3/2. We don't know what b is. Okay, so what we can do is we're going to take one of our points here. We'll take our positive points. We're going to substitute it in. Let me show you what that looks like. We're going to say y, which is 6, is equal to 3/2, which is our m, times our x value, which is 3, plus b. So what we're doing is we're saying this point, if we put it into the slope intercept form, which is this right here, with the same slope that we have here, then it's gonna give us the equation of this line, because the slope between these 2 points is a slope between any 2 points on this line. Okay, so little mathy math. 6 is equal to 3/2 times 3 is 9/2 plus b. We're going to subtract 9/2 from both sides. All right, 6 over 1 is the same thing as 12 over 2. Okay, you can ask me about fractions later on if you need to, and I don't mind helping you on that. Okay, but 12 over 2 minus 9 over 2 is 3 over 2, which is our b. So that means that our equation is y is equal to 3/2 x plus 3 over 2. That is how we get that. Believe it or not, this is the easiest way. All right, let us continue. Find the average rate of change of h of x, that complicated equation, from x equals -1 to x is equal to 2. Simplify your answer as much as possible. All right, so the rate of change is an average rate of change. The slope is an application of that. Okay, so our formula, delta y over delta x, still works. But that is, that would be h of 2 minus h of 1, h of -1 over 2 minus -1. Because these are my x values, and x is changing from -1 to 2. All right, so we have to do h of 2, and find out h of 2 and h of -1, and plug them into there as well. All right, so h of 2 is equal to 2 times 2 cubed minus 2 times 2 squared minus 3. Okay, so that is equal to 2 times 8 minus 2 times 4 minus 3. That is 16 minus 8 minus 3, which is equal to 5. All right. And h of -1 is 2 times -1 cubed minus 2 times -1 squared minus 3, which is equal to -1 cubed is -1. But let's just do it like this. 2 times -1 minus 1 squared. -1 squared is 1. Minus 2 times 1 minus 3. This is equal to -2 minus 2 minus 3. So that is 2 minus 2 is 4. That's 7, -7. Okay, so if we go back up to our equation up here, let's change this color. We end up with h of 2, which is 5, minus -7 over 2 minus -1. Whenever you subtract a negative, it's the same as adding a positive. So this is 5 plus 7 over 2 plus 1, which is 12 divided by 3, which is 4. That may seem like a lot of work. Kind of is. Well, it's not bad. The harder part is just staying organized with what you see. H of 2, h of -1, and then you just plug it into this rate of change formula. Okay, so as far as operations, it's not very much. It's just organization. Let's continue. Lucy is driving a race car. The table gives the distance she is driven at a few times after she starts. Boom, bada boom. Find the average rate of change of the distance from 0 seconds to 4 seconds. Okay, so that is d of 0 minus, actually I should do d of 4. I mean, I could do it, you can technically do it either way. I just want to keep it honest. D of 4 minus d of 0 over 4 minus 0. You see why I did it. I want to keep it positive. So d of 4 is 166.4 minus d of 0 is 0 over 4 minus 0. So 166.4 over 4. And my answer is, put it right down here, 41.6 meters per second. That part is fun. What's not so fun is we have to do it again, only for from 6 to 10. Same formula. I'll do it up here. D of 10 minus d of 6 over 10 minus 6. So 239.6 minus 172.8 over 4. Put in your calculator. 239.6 minus 172.8 equals 66.8 divided by 4 is 16.7. Same formula. All right, let's keep going. This is fun, but not fun at the same time. So we have a line here. Okay. Find the equation of a line that's parallel to this line and passes through the point -7, -5. So we're going to do something called point slope form to help us. It is very simple, but the main idea that we need a point and a slope. We have a point, and we have the slope. So the point slope is y minus y sub 1 is equal to m times x minus x sub 1. This is an alternate way of doing what we did earlier, but it's less steps, in my opinion. But whichever one works for you. So for this problem, parallel means it has the same slope. So y minus y sub 1 is the y value. So y minus -5 is equal to -7 over 6 times x minus -7. The slope is the same slope as this. So now, little algebra. Y plus 5 is equal to -7 over 6 x. This becomes plus 7. So it ends up becoming a minus again. Minus 7 times 7 is 49 over 6, which does not go evenly. We subtract 5 from both sides. And 5 is equal to minus 30 over 6, because 30 divided by 6 is 5. So we get y being equal to -7 over 6x. And then you get 49, -49 plus -30, or -49 minus 30, which is minus 79 over 6. And this is the equation of the line parallel that passes through that point. So for B, we want a line perpendicular to this line that passes through that point, same point. So let's change the color. So this slope, so if the original slope is -7 over 6, that means that the new slope is, or the slope of the perpendicular line is 6/7. Negative reciprocal, negative 7/6. Positive 6/7. So we do the same thing. Y minus y sub 1 is equal to m times x minus x sub 1. I like to write the formula every time so I don't forget it. So I end up with y plus 5, I'm just skipping down to here, is equal to 6/7 times x plus 7. All right, I just skipped a step. I skipped a step. Rather than doing x minus -7 or y minus -5, I already know that this is y plus 5 and x plus 7. So I just put those in there. Okay, if you can't skip a step, don't skip it. All right, so little multiplication. Y plus 5 is equal to 6/7 x plus 7 times 6/7. 7 divided by 7 is 1 times 6 is 6. You can talk to me about multiplying, dividing fractions. Minus 5, end up with y being equal to 6/7 x plus 1. Helpful. Graphing calculator, not needed. I mean, you can check it with that if you want to. It isn't necessary though. Let us continue. Transform each graph as specified below. The graph y is equal to f of x is shown. Graph y is equal to 2 times f of x. Okay, so 0, what we're going to do is we're going to do this point by point. 0, 0, -2, 2, -4, 4. So my x's are the same. It's just my y, so my output is multiplied by 2. So 0, 0 stays the same. So -2, I normally get out +2. Because I'm multiplying that by 2, I get +4. -4, normally I get +4 as my output, but I multiply by 2, and I get +8. And then I graph them. Hopefully a lot better than that, but you get the idea. All right. So the graph y is equal to g of x is shown below. Graph y is equal to g of 2x. Okay, so this is g of x. So we're doing g of 2x. So in other words, I'm trying to see how I can explain it. The transformation is you're multiplying. It's like I need. Okay, so g. So for example, 0, 0 stays the same. We got that. Okay, so g of, in the points we have 2, -1, 4, -2, 1, -1, -2, and -2, -4. Okay, so to graph this is to get here. My x value is halved. So instead of 4, -2, it is 2, -2. I should do that in a different color. Purple green. All right, so that becomes that. This 2 becomes 1 to get the same output. Okay, this -1 becomes 1/2. This -2 becomes -1. So it looks like this. So it's like, so when you see that 2x, that is actually a horizontal compression. All right, if that 2 was a 1/2, so if it was g of 1/2 x, it'd be a horizontal stretch. But this is a shrink. Transformations, fun stuff. Number 7, the graph of g of x is shown. Draw the graph of 2g of x plus 4. Okay, so the 2 is not with that. So this is a vertical stretch, and then you're shifting up 4. This is a vertical stretch of 2, and then you're going up 4. All right, so let's do it in order. So the first transformation, so g of x, so this becomes, hold on, vertical multiplied by 2. So g of x is -1, that becomes -2. -2 is -4. I'm multiplying the y values. 2 times -2 is -4. 0 just is 0. And -4 becomes -8. Okay, so it becomes, so it does, the first transformation is this. So this just deals with the 2. Now we're going to shift everyone up 4, and we're going to change colors. To do that, we'll go back to blue. So 0, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Right. So this does that. The blue is the 1. All right. We multiply the output times 2, and then we shifted it up 4. That's the easiest way that it works for me. I mean, for me to understand it is 2 on the outside means I multiply by 2, the output times 2. Let's keep going. So the graph of y is equal to f of x is shown. Draw the graph of y is equal to negative f of x minus 3. So it's x minus 3. So we're going to do x plus 3 because it's inside with the x, so it moves. So we're going to move this over first, and then we're going to do the negative. So everybody moves over 3. 1, 2, 3. 1, 2, 3. It's -4, so 1, 2, 3. That is the first transformation. I moved it over. I moved it to the right 3. Okay, and now I'm going to flip it. That negative on the outside of that f means I multiply everybody by -1. But as far as the outputs, by -1 because it's outside. But these two outputs are 0. So we just do this one. So the 4 times -1 is 4. And it becomes that. Cool, right? Below is the graph. Goodness. Below is the graph of y is equal to x cubed. Transform it to make it the graph of y is equal to 2 times x minus 4 cubed plus 3. Okay, that's not bad. All right, so first we're going to take this center. That's easy. We're going to move it to the right 4 and up 3. 1, 2, 3, 4, 1, 2, 3. Okay. So normally it's like this. So you see that we have 1, 1 as a point, and -1, -1 as a point. We're multiplying the output times 2. So whereas this point will move, we have a point here and here. All right, if we multiply by 2, that point moves to be here and here. Now, it may look like we could have multiplied it by 2 and then transformed it. That is a true statement in this case. All right, so this becomes like that. So we could have multiplied by 2 and then shifted it. But a lot of times it's easier to shift it first and then do your work. Man. All right, the graph of f in blue is translated a whole number of units horizontally and vertically to obtain the graph of g. The function f is divided by f of x is equal to x squared. What's g? Okay, so we're moving right 4, and we're moving up 2. So we do x minus 4 squared, because this is moving right 4, so this is minus, because when it's in with the x, it does the opposite. So right 4, and then we go up 2. Boom. Woo! Keep going. Problem number 10, almost there. For each graph, select all symmetries that apply. Well, this graph is obviously not symmetric to the x-axis. It's not symmetric to the y-axis. It is symmetric to the origin. Actually, let's put a circle around that. Symmetric to the origin just means you can it has rotational symmetry. I can rotate it 180 degrees around this point, and it will map onto itself. Okay. Symmetry for the circle, x-axis, y-axis, and origin. It's a circle. You can flip it and rotate it around anyway. It's going to do the right thing. Part C is symmetric to the x-axis. We can see that pretty easily. This is the line of reflection right here. All right, now the other ones. Whew. Piecewise function. Here we go. So h of -2. X is not equal to -2 here. X is equal to -2 here. So h of negative, let me write it over here. So h of -2 is -2 plus 1 squared minus 3, which is -2 plus 1 is -1. -1 squared is 1 minus 3 to -2. Okay, h of -1. H doesn't equal -1 here. H equals -1 here. So h of -1. No, h is -1 here. That's positive 1. H is -1 here. Same form, same type function. So this is -1 plus 1 squared minus 3. -1 plus 1 is 0. So that's -3. And h of 4 falls into this interval. So the answer is -4. Put boxes around these so we can find them. Okay, whenever you're evaluating these functions, you're looking to see which one of these intervals does it fit in. And that tells you which one of these rules apply. All right. Separate each interval with a comma. Use as few intervals as possible. Okay, so now we're trying to see which intervals is this function decreasing. So this function is decreasing from -5 to -3 This function is decreasing from 2 to 3. They asked us to list them. They didn't ask us to unionize them. Unionize her. Or to make a union. So this is our answer. Here's a graph of f. Find all local minimum values of f. So the minimum values of f are at, hold on. Find the local minimum values. -3 and -5. They didn't ask where the local minimum. They didn't ask where the local minimum was. They asked what is the value, which is the y value. The minimum is that. That's A. B, all values at which it has a local minimum. It has a local minimum at -2. There's a local minimum at 4. So this should be -3, -5. And that should be -2 and 4. Reading the question is important, as I demonstrated earlier. All right. 14. Graph the function. Okay, this is a piecewise function. So let's dive in. So -3 if x is between -3.5 to -2.5. So -3.5, open circle, to -2.5, close circle. Boom. And -2 from -2.5 is going to equal -2 there. So -2.5, open circle, to -1.5, close circle. -1 from -1.5 to -0.5. 0 from -0.5, open circle, to 0.5, positive 0.5, close circle. So, and 1 from 0.5, open circle. They switched it up on me a little bit, I see here, Okay, so let's go back and look at this. At -1, there are 2 open circles. And then here, there's a closed circle. Let me erase that too. Here, there's a closed circle here. And an open circle here. So here, 1, this is a closed circle here, to an open circle here. Boom. Hard part. Look for your equal, your greater than or equal to or less than or equal to. You see, I skipped this one, or I overlooked this one. I thought it was the same pattern, and the pattern changed on me. So hence, you got to pay attention. All right. 15. Suppose that function is defined for all real numbers. Graph the function, determine whether or not the function is continuous. We just having big fun today. So let's do it. So at x equal 1 is -x plus 2. So 1 plus 2. So 1, 1 is my out. Is it my out? It's not a vertex, but it kind of is. Okay. So 2x minus 1 for the first one. This will be my y-intercept. So I'm graphing the top function now. 2x minus 1. So I start at -1. I go up 2 over 1. That's that guy. So it beats up with that. Then I go down 2 left 1. Down 2 left 1. Down 2 left 1. That's all the slope is the pattern of what we're doing. So then I can connect these. Boom, 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 boom. All right, and then Negative x plus 2 means negative 1 is the slope, which means down 1 over 1. So I can do this. Let's do some points. This one, this one, this one, this one. And I can just go. Boom. Is this function continuous? Can I draw this without picking my pencil up off of my paper? Yes, I can. You can pause and rewind and go through that again if you need to. It's not hard. It's really the hard part is just organizing what you're doing. All right. I know for the function, 2 is the slope, negative 1 is the intercept. For this function, 2 is the intercept, but we're not defined back here. But you see, if I kept going up, I would hit 2. And I just go, it's negative 1 is the slope. So I just go down 1 over 1. Just on through. Again, hit me with questions on this. 16. For the 4 functions are below, either the function is defined explicitly or the entire graph is shown. For each, decide whether it is an even, odd, or neither. Okay, this function, I can rotate it and map onto itself. Odd. This function, I can reflect over the y-axis and it maps onto itself. Even. Okay. These functions, there is a easy way to do it, but I'll let you ask me what the easy way is. I'll show you the official definition. So you have g of x. If g of x is equal to g of negative x, it's even. If negative g of x is equal to g of negative x, then it is odd. So if positive, so if I can put in a positive and negative number of the same number and get the same output, then it's even. If I put in a negative number and then it's kind of the opposite output, then it's odd. So g of x is this. G of negative x is, you just put negative x in. Negative x to the 4th minus 4 of negative x cubed. All right, this becomes, raising a negative to an even power makes it positive. 5x to the 4th. Raising a negative number to an odd power leaves it negative. So that becomes minus negative 4x cubed. So that becomes plus 4x cubed. That's g of a negative x. And negative g of x means you just multiply the whole thing by negative 1. Negative 5x to the 4th plus 4x cubed. So g of x is this. G of negative x is different. Negative g of x is different than g of x. So this is neither. Okay, for h of x, let me change colors and let me bring it over here to show you how to do it. It's not as complicated as it looks. H of x is equal to 2x cubed. H of negative x is equal to negative 2x cubed. And negative h of x is equal to negative 2x cubed. These two are equal to each other, so it's odd. If the first two were equal to each other, then it would be even. So this is how you do it, and it's a lot easier. All right, 17. Here we go. So is f of 1 positive? This is 1. Is f of 1 positive? Nope. For which values is x? For which values of x is f of x greater than or equal to 0? That means where is it above the x-axis? That is from not 0. I'm doing. That is from -4 to -1 union 2 to 4 because it's above the x-axis on those intervals. For which values is f of x equal to 0? Is equal to 0 at -4, is equal to 0 at -1, and it is equal to 0 at 2. I'm blue right now. Here, here, and here. All right. 18. Graph the system and write a solution. Okay. The first thing we want to do is we want to, there's a few different ways to do this. They ask us to graph it, so we'll graph it. But you can definitely use your graphing calculator to graph this. We need both of these in standard form. Well, in slope-intercept form. So I'm going to add 2x to both sides. And I get here y is equal to 2x minus 6. And I get y is equal to 1/3 x minus 1. Now, I kind of hesitate to to graph this so much because your graphic calculator will do this. But let's do it. So 2x, -2x minus 6. Gotcha. So -6, because that's my, so we'll do these graphs. This will be red, and this will be blue. So red, -6, you go here. And then my slope is 2, which is the same as 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. I like to cross my axes to get any intercepts I have. Up 2 over 1, up 2 over 1. All right, and then I see my pattern. I can just connect the dots. Up 2 over 1. Try to straighten that out a little bit. Yeah, try to straighten it out a little bit. All right, for the blue one, go to -1. And then the slope is 1/3. So up 1 over 1, 2, 3. Crosses there. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Connect our dots. All right, and the solution is at 3, 0. And if I'm not mistaken, that is the end of this. I hope that it is helpful. Definitely ask questions about this if you so need to.